Hello and welcome to Discovery at Home. My name is Jillian and I'm a science educator at the Discovery Center. I'm so excited to be streaming to you live today so you can learn something new and have fun with science. Today's episode, Matter of Fact, is all about matter. Not sure what matter is? Stick around to find out and create a cool looking tower of liquids and solids for today's hands-on activity. While we're waiting for others to join the stream, let me tell you a story that involves mixing and experimenting with matter to help us get thinking about today's topic. My story involves a product that was created through some at-home science and became known worldwide. Do you know what it is? In the year 1922, Edward Perkins created a concentrated liquid drink mix called Fruit Smack. But I'm sure you've probably never heard of this because this is not the product that came to be known around the world. Perkins realized that this early liquid version of the drink was very expensive to ship through the mail to his customers. That's because water is very heavy. So he planned to figure out a way to remove that liquid. In 1927, Mr. Perkins figured out a way to remove the liquid, leaving only a solid powder behind, creating the famous drink mix, as you know it, Kool-Aid. And it's still around today, 93 years later. It's all created, which I think is really neat, through some at-home science experiments which were done right from Edward Perkins' mom's kitchen. The reason I'm telling you this story is because I want you to be inspired to test your own ideas using hands-on science. And a great place to start is the kitchen because there are lots of safe food ingredients that can be mixed together. So I also wanted to bring this story up to help us get thinking about solids, liquids, and mixtures. So I want you to think about how we take that powdered Kool-Aid, those tiny bits of solid, and turn it back into a drink, like my liquid here. So what else do we add? What do we do to get those things to mix together? Can you think of other examples where we mix liquids and solids to make something new? Now that we're thinking about solids, liquids, and mixing them together, before we dive right into the facts of the matter with Adam, I want to welcome anyone who joined after the beginning of the stream. Welcome to our Matter of Fact workshop. My name is Jillian, and I'm a science educator at the Discovery Center. Today, we will learn what matter is, and we will investigate liquids, solids, and mixtures. We will also make a neat-looking tower of different liquids to see which float or sink, or if they mix together. And we can add some solids, like the Lego there, to see which liquids they sink or float in. Once you've made your tower of matter, be sure to share a photo or video with us and tune back in so we can talk about your results together. Every time you share your science with the Discovery Center, you will be entered in our contest to win a Science at Home prize pack. You can share your results on Flipgrid as well as Facebook or Twitter, and be sure to tag the Discovery Center. Now it's time to hand it over to Adam to tell you all about matter, mixing, and how to set up today's fun activity. Are you ready to get mixing?
Hi everyone, and welcome to the Matter of Fact workshop. My name is Adam, and I'm one of the science educators at the Discovery Center. Today, we will be learning about states of matter by investigating some properties of liquids and solids. To guide this investigation, we're going to start by asking a general question. How do you think different kinds of solids and liquids mix and interact with each other? This is a big question, but we're going to explore parts of it by making a multiphasic tower. That's my attempt to give a fancy name to the tower that we're going to make by layering different liquids and solids. I'm going to start with some background information before setting up to make a tower myself. While we're going through things, I suggest you, like a good scientist or engineer, take some notes. You can do that in whatever mix of words and drawings that you like. The point of that is to collect details that will help you make your own tower and answer our question. Now, let's start from the start. I told you that we're going to be talking about states of matter, and we've called this program Matter of Fact. So we better ask, what is matter? Matter is anything that has mass or weight and takes up space. Matter is made up of tiny particles that are so small that we can't even come close to seeing them with our eyes, or even with the best possible light microscope. although scientists have figured out some really cool ways to learn about them and even generate pictures of some. Everything around us is made of these particles. Computers, water, air, and even you are made of these particles. They are so tiny that it takes an incredible number of them to make something at our human scale. Try to imagine the number of drops of water in all of the Earth's oceans. This massive number of particles are also always moving, whether that's zipping around and bumping into each other or just vibrating. We usually group matter into 3 states based on how their particles are interacting with each other. We call the states solid, liquid, and gas. In solids, like ice, particles are locked together. They're still moving, spinning, vibrating, bouncing, and twisting, but not traveling around because they're stuck to and locked together with their neighbors. Imagine you're at a dance where everybody's holding hands, not in pairs, but as a group, connecting everybody. You can dance in your own spot and bump into your neighbors, but you can't move around the room. In a liquid, like water, that dance gets livelier. The particles have more freedom to move, although they tend to stay fairly close together. It's still a packed dance, and you're bumping into your neighbors, but only holding hands briefly before spinning off through the crowd and dancing with other partners, like a really disorganized Kaylee. In a gas, like air, my dance metaphor starts to break down. Particles now have so much energy, they're so lively that they start to spread further apart from each other and can move around very easily. In a gas dance, people wouldn't be holding hands anymore. They'd be zipping all around the hall with jetpacks or something up in the air, bumping into each other and bouncing all over the place, just really out of hand. These different behaviors of the particles are why we see differences in the properties of things that are in the form of a solid, liquid, and gas at our human scale. Instead of just relying on my dance description, I'm going to try to demonstrate some different particle movement in a solid versus a liquid using these marbles in my beakers. This is my example of a solid. See, the particles are in the bottom, and when I try to move them around, you can hear them jingle, but they aren't rolling around. They aren't moving from where they are. They're just vibrating against each other. Have another look. See what I mean? Now I'm going to compare that to a liquid. I'm going to prep a liquid out of my stock solution in this beaker. Here's my liquid marbles now. Watch what happens when I try to mix them. You can hear them jingling, but can you see them moving around also? These ones have enough freedom now to move around in their beaker. In my left hand, this is my solid, right? When I move it, they jingle, but they don't roll around. Here's my liquid. When I swirl it, can you see the particles moving around? Here's a noisy side-by-side demonstration for you. There's much more particle movement in my liquid. Each state of matter has its own special features or properties. We can explore these properties by using our senses, by checking to see how something feels, how it smells, what it looks like, and how it acts in different situations. Solids tend to hold their shape and be harder, while liquids can be slippery and move more easily. Can you think of or find some examples of solids around you? Maybe like my wooden table or my glass beakers that hold their shape even under pressure. One of the ways in which liquids differ from solids is that they don't hold their shape. They take the shape of whatever container they're in. I'm going to show you a little classic demonstration of pouring the same volume of liquid between 2 different shaped containers. I have just my colored water here in an Erlenmeyer flask, and I'm going to put, let's say, 100 mils in my graduated cylinder. I like the grad cylinder because it's so tall and skinny. So it kind of looks like it's big, but it's only 100 mils there. There's still 400 some left in my Erlenmeyer. Now let's compare that to my little beaker. There's a mark, we call this a 100 mil beaker, and the mark here is at 80. So 100 should be around here. Let's compare this much bigger looking grad cylinder to this little looking beaker. These two very different shaped containers were about the same volume. You see, the liquid will take on whatever shape of the container that we put it in. Liquids can also be thick or thin, changing how fast they slide down a surface or pour from a container. Do you know what I mean yet? Can you think of liquids that you've seen or played with that were thick or thin? A liquid that is very thick will move slowly. We might describe it as goopy or gooey or gloppy. When pouring something really thick, I can almost hear it in my imagination, making a sound like glop, glop, glop as it slowly pours out. A liquid that is very thin will move quickly. I'm imagining a nice smart stream coming out of a hose, making a higher pitched noise like a pshh. Do you think water or honey would win in a race down a hill? Which liquid is thicker? There's also an old saying about being as slow as molasses. Does that make more sense to you now? One of the implications of the thickness or thinness of a fluid that we'll use later is how quickly it will mix. I've prepared some materials for our salt and sand mixing experiment. I have 25 grams of table salt here that I'll put in my Erlenmeyer flask. A flask like this is made for swirling around and mixing things, so it's a good choice for what we're going to try. And I have some water. I also have 25 grams of sand that I'm going to put in here. It's kind of a funny color sand because it's a play sand that we use here in the center. So now, let's compare with the water. Let's try salt first. So here's 400 milliliters of salt on 25 grams of table salt. If you see tiny bits of steam coming off there, I use some warm tap water for this. And give it a little bit of a swirl. Kind of the opposite of the molasses. Things often happen quicker when they're warm. So warm water can make this quicker. So I'll let that sit for a minute and let's compare with our sand. Here's 400 milliliters of water on 25 grams of play sand. Right away, we're seeing it quite different, aren't we? This one got all hazy as though it's all mixed through it, but our sand is sitting right on the bottom. I'm going to give it a good mix. It's all swirling around through it. Nice vortex, but the sand's just spinning around on the bottom and starting to settle. Our salt, on the other hand, is starting to clear. It was all hazy before. Yeah, it's still a bit hazy, but it's getting more and more clear, and nothing's really settling on the bottom. Remember, we had the same weight of our two powders that we put in at the start, and even though we have to wait a little bit longer to get completely clear in the salt, look at that in the sand. It's completely sat on the bottom. So we put two things into each of these, right? We put in a solid and we put in a liquid. In the case of the sand, we still definitely have two things. Sand went in and water went in, and there's still just sand and water in there. But on the salt side of things, besides that tiny little bit that I'm still trying to dissolve, now there's only one thing in here. We put in salt and water, but now there's only one thing, salt water. So this one dissolved, and the sand did not. What do you think would happen if you tried to add a bunch of different liquids and solids into the same container? Well, that's the activity that you're going to do today. There are three types of materials that we'll need to build our tower. Firstly, we'll need a tall and narrow container with clear sides, such as a clear bottle, a glass, or a vase. I, of course, have my grad cylinder too, with handy volume markings. The reason we want to choose these tall, narrow ones is they're going to give us the cleanest looking layers using the least amount of materials. and preferably choose one that has a lid or can be sealed for easy mixing. Then we'll need substances to go in our towers. I suggest you choose at least 3 different liquids for your tower, such as water, cooking oil, baby oil, some syrup, or dish soap. Choose a variety so that some liquids are thinner and some liquids are thicker. Try to choose some that you think might be lighter and some that might be heavier. Also, be a good green chemist. Think about using things that are safe for you to handle and are also easy to dispose of safely for the environment. For example, if you want to use some oil, and oil is an interesting choice, choose a cooking oil rather than dirty old motor oil. There's also one other option that I wasn't sure if I wanted to include. Rubbing alcohol that you might use to clean a cut has very interesting properties for a tower like this, but if you look at the label, poison and flammable. So if you were going to consider using rubbing alcohol in yours, please get an adult to help you with it, both making it, playing with it, and disposing of it. A little tip here. If the mouth of your container is small, like in the bottle or in my grad cylinder, you might want to use a funnel to add your liquids to reduce mess. And depending on your choice of liquids, smooth pouring can make it much easier to get good, clean layers. Finally, choose at least 2 different solids to add to your tower, or to mix into the liquids to make solutions. There's lots of options, such as salt, sugar, sand, rocks or marbles, ice cubes, cork, wood, and Lego. Which of these will dissolve into a liquid? Which will float or sink? Now, in order to make your tower, gather and organize your solids and liquids for the different layers. When choosing your materials, think about how their properties compare, like how thick, thin, heavy, or light they are. Make some observations of other details, like how do your materials feel? How do they smell? What do they look like? And what do you think will happen when you put your materials together? How will they mix together? Use your organization and comparisons to choose what order you'd like to pour your liquids into your container to start making your tower. For my liquids, I've chosen a corn syrup, water with food coloring just to make it easy to see, and some canola oil. Then pour your liquids in carefully, one at a time. Can you make at least 3 separate layers of liquids? Do you notice any of the layers starting to mix? If so, think about why that happened. What would happen if you poured them in a different order? Would your tower look the same? I'm going to put mine together for you, and I'm going to use this glass. I know I mentioned that it's a good idea to have one with a top on so we can mix it well, but I thought this would be nice and clear on camera, and it would let me add some bigger solids into it again to make it easier for you to see. So I expect that my heavy, thick syrup is going to sit on the bottom, and I also expect it's not going to mix very well. So I'm going to put it in first, get it down there so it's not stuck on my sides. Let's put a few centimeters in. That looks like a nice layer. And now for the water. I'm going to try to pour carefully so it doesn't all mix in. Maybe a little bit to the side, down the side of the water. I see I'm disturbing it a little bit, but it's sitting pretty well. Let's keep going. A few more centimeters of the water. There you go. I can see where I disturbed the layer a bit, but it looks pretty good to me. Here's the oil on top. I'm going to pour carefully again, sideways on this big jug. And there it is, sitting on top of my water, even though I'm pouring a little too quickly and it's kind of bubbling through it a bit. Let's get a few more centimeters on top here. There we go. There's a few bubbles in there, but let's see if they sort themselves out. Can you see my nice 3 clear layers in there with my heavy syrup sitting on the bottom, my in-between water in between, and my oil on top? Once you have your layers of liquids, place your solids in the tower you just made. What happens to them? Do they float or sink? Where do they end up in your tower? For my tower, I've chosen 3 different solids to show you. Ones that I don't think will dissolve, but that will sit in my tower. I've chosen some ice that I've dyed red just to make it easier to see, some Lego, and a marble. I'm going to put them in the order that I think they're going to sit. My marble's the heaviest one, so I think it'll sit at the bottom. Let's see. Here goes. Right through all the layers, and did you see it slow down a bit in the syrup? The syrup kind of caught it, but it is sitting on the bottom. I think from cleaning Lego, they do sink in water, so I'm going to put that in next, but because there's some air in it, because it's a little bit hollow, I'm going to have to try to sink it. It's a little bit floating on me, but I wonder, is that catching oil? I'm going to hold it down for a sec and see if that helps. Looks like it's ending up in my oil layer. Great. And here's my ice cube. So, looks like the marble is nicely set on the bottom. The ice cube is floating kind of low in the water, and the Lego, wrapped up in the oil, is floating very high on the water right in the oil layer. Cool. I want to show you another tower now that I'm going to mix very gently. I have 3 liquids to put in it. One is my water with a little bit of coloring, and some canola oil, and my isopropanol with a bit of food coloring. Because I'm working with my isopropanol, I'm going to make sure to use my safety glasses. I'm going to layer these in the order that I think they will sit by themselves. So let's start off with about 30 milliliters of the heavy water. There we go. And on top of that, let's add our lighter canola oil. Go, sitting nicely on top. No fear of the oil and water mixing. There we go. There's another 25 milliliters of oil. And now I'm going to put the isopropanol on top. There we go. And let's see, a few more milliliters. Bring it up to the 80. That's giving us about 25 of the isopropanol, 25 of the oil, and about 30 of water. Nice clear separation, highlighted by the colors. But now I'm going to try to mix it, and I'm going to do it gently. I want the layers to kind of be able to touch each other, but not really froth it up and cause trouble. Here goes. Maybe give it a 1, 2, 3. Here's a 1. Oh, 1 might be plenty. Let's see. See more of that red at the top. Things are bubbling through. It's a little darker down the bottom, kind of that purpley from the blue dye in the water. Let's see, do we see any layers reforming? I see some oil collecting up there. That's looking pretty good. It looks like this. If you remember me saying that you might want to wait a few seconds and then a few minutes to see what happens, we have some interesting things happening in a few seconds, but it looks like we might want to wait a few minutes to see what really ends up happening with this. So if you want to try inverting yours and mixing it up, give it some time to separate back out and see if all your layers are still there or if they've changed and mixed together. I hope you...
Thanks, Adam. Friends at home, I hope Adam was able to help you better understand the states of matter and how things mix. Now that you're all set with Adam's suggestions, are you ready to get mixing? If you missed Adam's how-to or want to rewatch parts of the background science about matter, you can rewind anytime during the live stream. If you've just tuned in and want to take part in today's activity, I would recommend rewinding now so you have all the instructions you need to make your liquid tower. You can also find the learning guide on our Discovery at Home webpage to help you with today's activity. You can use that space on the learning guide to draw your results, showing the different liquids and solids you included in your tower. If you have any questions while you're making the tower or trying out different mixtures, please reach out on our Discovery at Home page. Our team of educators is online to help you out. When your activity is complete, please share your science with us using Flipgrid or social media and tag the Discovery Center. Your Discovery Center tagged submission enters you into our Show Us Your Science contest for a chance to win that Science at Home prize pack. Friends, are you ready to get mixing? Don't forget, share your results at any time. So if you are rewinding to rewatch, that's okay. Just remember, if you do want your creations to be sent in and featured on our live stream, you have until 10:55 to include it in today's show. Join me again at 11 so we can have a look at your liquid layers and mixtures. I'll also have a neat chemistry experiment that includes all 3 states of matter in one container. I can't wait to see what you mix up, and I'll see you soon. Hello, and welcome back to our Discovery at Home workshop, Mixing Matter. If you're tuning in now for the first time, my name is Jillian, and I'm a science educator at the Discovery Center. Before the break, we learned about states of matter, solids, liquids, and gases. Talked about mixing and learned what we need in order to create a layered liquid tower. If you missed this background science with Adam and would like to try today's activity, you can rewind anytime to watch what you've missed, or can continue to watch live now to check out others' results and to get some inspiration. You can also find a learning guide with the background science and our suggested materials on the Discovery at Home webpage. If you haven't already shared your science with us, it's not too late to be entered into our Show Us Your Science contest. When you send in your science experiments on Flipgrid and social media, you'll be entered into a draw for a Science at Home prize pack. Don't forget to tag the Discovery Center. All right. For those of you who did send in your creations already, let's see how they turned out. I've got some pretty cool looking layers. All right, our first liquid tower was sent in by JK, and JK left us a little message there that there is some mixing in the layers. Maybe in that green layer, I see kind of a fuzzy border between the green layer and that white layer below. Let's see what happens. Awesome, syrup, milk, dish soap, water, and oil in those layers. Looks great. We're gonna add some solids to see if we can get things sinking. Looks like the Looney made it all the way to the bottom. And a sugar cube. Hard to tell with those opaque layers just where that sugar cube ended up. I'd be interested to hear where in that tower it turned up. And a ping pong ball floating nicely on the oil right at the top. Great job. Let's see our next liquid tower creation. Our next one was Mixing Matter by Cameron, and it looks like Cameron has used some dish soap, some cooking oil, maybe some water, and maybe a bit of food coloring there. And I see a couple solids to be added in. Let's see if that goldfish cracker is going to swim or sink. We've got our dish soap and water. Next comes the oil. And it's hard to tell if our dish soap and water might be mixing a little bit there. In goes the blueberry, and it sunk. And our fish is happily swimming right on the top. Great job with your mixing there. All right. Are we going to shake it? I'd be interested to see what would happen if you shook that mixture. See if that dish soap and water does mix in a little bit more. Awesome job. Our next submission was sent in by Nikolass, and Nikolass had quite a few liquids on the go there. And Nikolass, you stole my thunder. I also brought some molasses to test out in just a bit. Let's see how your results turned out first.
Okay, so what we did, we used 4 of them actually instead of 3. The bottom we used pure molasses. Then we did syrup, water, which is right there, which we added green food coloring. Then we added vegetable oil on the top, which you can see. We were going to use it in this, but Mom decided to use this one. And yeah.
4 different layers.
4 different layers. In order. Goodness. And dun, dun, dun. This, I'm gonna shift it over. Yeah, it's pretty cool. I was thinking maybe we could get a 5th layer. I was like, nah. Well, bye. I'm gonna wait a few more seconds for it to turn off, and peace.
Great job, Nicholas. I loved that you tried to get more layers in there, and it was really cool that you organized all your materials at the end to show us where those layers sorted out into your cup. That makes me think that probably with my molasses, I think watching yours, that it might sink to the bottom of my layer, so we'll have to wait and see. I have one more wonderful creation sent in by Malcolm. Let's check this one out. They've got 2 on the go here with some different objects floating and sinking, and a question for us as well. Let's have a look.
These are the materials that we put in there. We have sand, rocks, vinegar, cooking oil, there's some apples, and dish soap. And the layers are, there's some sand on the bottom and some rocks on the bottom. There's some colored water and some vinegar on the bottom, and some cooking oil on the top, and some Lego.
It's only been a few minutes, and some of the Lego are on the bottom, and some of them are on the top. Another question I have is, why do some seeds float and some seeds sink?
Awesome job. I like that you had so many different layers, and also a question in there for me. Some of your Lego was sinking and some of the Lego was floating. I wonder if the pieces that made it to the bottom, were they bigger pieces? It all packs down to how that matter is packed into your Lego. And maybe if you have more of those little particles packed into a space or a bigger piece of Lego, it might be heavy enough to sink. But the smaller pieces, I would bet, are the ones that are floating right at the top. You also had a great question about why some seeds sink and other seeds float. And this is a great question. Again, it all comes back to how particles are packed inside something, and also air. Some seeds, I could imagine, are pretty dense, which means inside that little seed, there might be a lot of particles packed tightly together. There also might not be a lot of air. But in other seeds, those particles might not be packed quite as tight, and there could be a little pocket of air that helps that seed float. I hope that answered your question. It's all down to matter and how it's packed, and if there's air, to give it a little extra help to float. Awesome job with all of those viewer submissions. Thank you for sending in your amazing towers. I was also inspired to try this out myself, but before I do show you that, I have another viewer question that came in on our Discovery at Home page. And the question was, it's easy to add salt to water, just like you saw through Adam's video, but can we take it back out again? And this question was sent in by Alex. Alex, that's a wonderful question. It's a little harder to take the salt back out, but it absolutely can be done. We call this process desalination. Now, it happens naturally in nature. If you've ever been walking along a shoreline by the ocean at low tide and notice little white streaks on the rocks or the sand, that's actually sea salt. What's happened is over the day, maybe it's been sunny and warm, the water has evaporated away and left behind those bigger, heavier particles or molecules of salt. It's also an interesting thing to think that this relates to climate change. As our Earth gets a little hotter and we need to be really careful with our water sources, especially fresh water, there may be ways that we can look to salt water to remove that salt and use it as drinking water. And there are countries now in the world that are already doing this. For example, there's a huge desalination plant in Saudi Arabia that turns salt ocean water into fresh water. And one way you could do this at home, but if you want to try, I would recommend definitely have an adult help you and ask for permission first. But you could try adding salt to water, just like Adam did. Put it in a kitchen saucepan and watch it boil on the stove over time. The longer it boils, the more the water molecules will evaporate, and eventually you can be left with some crusty bits of salt right in the bottom. Again, if you want to try this, make sure you ask an adult first, but it's a great way to see matter in action. All right, now I am excited to see where my liquids go. I want to try this out like Adam's, and I'm going to make one just like his, but I have a few other liquids that I want to see where they mix in, and one of them I already mentioned was molasses. Adam mentioned things being as slow as molasses and that it's pretty thick. Seems pretty heavy to me too, so I thought it might go all the way to the bottom, and I expect after seeing Nikolass's results, it probably will. I also wanted to see where baby oil fits in, because Adam used cooking oil in his experiment, and I want to know if that baby oil will sink in the other oil, will it mix with the baby oil, or will it float on top? So let's find out what happens. I'll grab my corn syrup first, because that's what Adam had right at the bottom, and add it into my glass. All right, I think that's probably good. So I've got a thick syrupy mixture at the bottom. Let's add the baby oil next and see what happens. So I can tell, and I don't know how well you can see it on camera, as I squirt it, there's a lot of turbulence in those molecules, and they look like they were going down. Now, it's tough to see with two clear liquids, but there is a divide. Yeah, it's pretty clear actually, for me. I'm not sure how well you can see that, but I'll get another liquid in there to see if I can help you out. So I've got my corn syrup at the bottom, my baby oil. Let's add the cooking oil and see where it goes. So I'm seeing some interesting results here. It does look like I might have a bit of mixing between my cooking oil and my baby oil. So they might be pretty similar in the way their materials are packed together and maybe pretty similar makeup of their molecules. All right, let's add in some colored water. I'll go for the big beaker with the bluish purple color and see where that sits. Aha, so now we have some better separation of those layers. That heavier, more dense water has sunk down through my layers of cooking oil and baby oil, but it's still not as thick and heavy as that corn syrup right on the bottom. Okay, for the last little bit, let's see where my slow, thick, heavy molasses ends up. Oh, I'm getting kind of a surprising result. I was actually expecting it to be thicker and heavier than the corn syrup on the bottom, but I'm surprised. It's actually sitting right on top. Let's see what happens when we give it a little bit of energy and mix things around. We'll get to see how those layers separate out again, or if they mix. Oh, it's pretty gloopy and thick at the bottom. But I think I am noticing that my layers of molasses and corn syrup look like they have mixed into a very muddy looking mixture. And it also looks like my water has mixed in with the two as well. So I'm left with a gloopy layer, a mixture of molasses, water, and some corn syrup, and my oils sitting right on the top. So now that I have my tower all set up and I've made some observations, I have a bit of a chemistry surprise for you to end today's show. Near the beginning of the workshop, Adam talked about the 3 states of matter being solid, liquid, and gas, but we haven't really talked a whole lot about gas today. So I've brought in an experiment that will bring back that gas. Okay. Here I've got my container, and inside we see that I have some water, and at the top I have cooking oil. So I've got 2 liquids in there. But I'm going to add another liquid. Let me just grab it. My food coloring. Okay, so my food coloring, I would usually expect to fall down to the bottom because it's mostly liquid-based, water-based, just like my water at the bottom. But sometimes if I make tiny little drops, they are too light to sink down through the oil and make it to the water at the bottom. So I've brought along a solid to help me with that. So there's a fun way that we can hopefully get these things mixing by a chemical reaction. Let's see. All right, I'm gonna add my food coloring really slowly and hope that it doesn't sink and it's sitting nicely on top of the oil. Great. Add a bunch of drops. Oh, some of it is starting to sink. That's okay. And now notice that it's getting trapped in that interface between water and cooking oil. Cool. So we'll see what happens when we add the solid. Okay. Now, before I do add my solid, I want to thank everybody who joined the stream today, who sent in their videos. I had a great time getting to mix some matter with all of you. Okay, are you ready to see what happens? I want to thank you all so much and remind you to keep on mixing and stay curious. All for today, my friends. Thanks so much for joining us and having some fun mixing matter. We'll see you again real soon.